All right, so I've seen some of you guys have problems with chain rule. So let's do it right now, and please excuse my poor handwriting. So let's start off easy. So if I told you cosine of x squared, is that chain rule? Of course it is, because here we have an outside, we have an inside. What's the derivative of the outside? Negative sine. And now whatever was inside, just kind of bring it over, bring it down, times, now what's the derivative of the inside? 2x. And that was a very short chain rule. But now let's look at a chain rule that's not as easy. Let's do tangent of e to the cosine of the sine of x squared, parentheses, 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 and let's have all that to the fifth power. Now that's complicated as hell. But if you take it step by step, you'll be fine. Here, on the outside, we see something to the fifth power. Now, that something could have been secant, cosine, I don't care. It's something to the fifth. And we know something to the fifth is 5 times that something to the fourth. All right, so that's our first layer done. All right, let's keep going. So our first layer is done. Now, we're going to multiply. Let's keep going in. Now, we're going to pretend as if that outside layer never existed. Okay, so what's the derivative of tangent? Oh, well, that's secant squared. Oh, but it has some inside stuff, so we just carry over all that inside stuff. Now let's move on. What's the derivative of e? Well, derivative of e to anything is e to that anything. But yeah, you just bring it over. Now we keep going. What's the derivative of cosine? Oh, well, that's negative sine. Oh, but it has some inside stuff. So you bring over whatever that inside stuff was. Now you keep going. Derivative of sine is cosine, and cosine had some inside stuff. And that derivative of that inside stuff is 2x. And boom, there's your derivative. I guess the most confusing part, really, would be, when do I stop, Milos? Like, I get what you did, but I never really understand when to stop. Well, check it out. Inside the fifth was a tangent. Inside the tangent was an e and yada, yada, yada. Inside the x squared is just an x. So, if we want to take the derivative of 2x, if we want to take the derivative of x, what is that? That's just 1. That doesn't really do much. We're done. But here's the kicker. I can now take out this x squared. I could say that's, I don't know, let's do another tangent, right? Because why not? So, this would have become a tangent of x. And that derivative is one more secant squared of x. And that's how they can make it complicated, by just keep replacing the x and putting something new in there. But it's just one extra step.